Hey everyone, and welcome. Today, we're diving deep into the core concepts of TypeScript. We're talking about the fundamental building blocks that lets you write cleaner, safer, and just all-around better code. So let's get right to it.
So just think about this for a sec. What if, while you were typing, your code had its own built-in safety net? One that could catch silly mistakes and potential bugs before you even hit the run button. Sounds pretty incredible, right?
Well, that's exactly the promise of TypeScript. It's not some completely new language you have to learn from scratch. Nope, it's simply JavaScript, but with, well, superpowers. The main superpower is the ability to understand types, which makes your code way more robust and predictable.
So, how does it actually pull this off? Well, the very first building block is all about describing the shape of our data. And to do that, TypeScript gives us two main tools, types and interfaces. First up, we've got the type alias. Think of this as a super flexible label you can create for any kind of data. For example, we can create a type called size that can only be one of three specific strings, small, medium, or large. This is what's known as a union type, and it's fantastic for preventing typos and ensuring a variable holds only the values you expect.
And then we have the interface. Now, if a type is kind of like a jack of all trades, an interface is a specialist. Its main job, its whole purpose in life, is to be a blueprint for objects. It lets you define exactly what an object should look like, what properties it has, and what it can do.
Okay, so this brings up the big question that everybody asks. When should I use a type, and when should I use an interface? The simple answer is that a type is more versatile. It can handle things like unions that interfaces can't. But interfaces are specifically designed for object shapes and have this really cool feature called declaration merging, which can be a lifesaver in bigger projects.
But types can do something even cooler. They are just static, boring labels. They can actually be programmatic. TypeScript can literally generate new, complex types for you based on other types you've already defined.
Yeah, for real. Let me show you.
Check this out. This is the magic of template union types. So we've got one type for our supported languages and another for different sections of a web page. Now look at that last line. By combining them in a template string, TypeScript automatically creates a brand new type with every possible combination, en_header ID, pt_footer ID, and all the rest. No more tedious manual work.
Okay, so we know how to describe the shape of our data. That's awesome. But data usually doesn't just sit there. It needs to do things. The next step is to bundle our data together with behavior, and for that, we turn to classes.
Building a class in TypeScript is actually a really straightforward four-step deal. First, you define the class itself. Then, you add the properties, the data that it's going to hold. Step 3, you create a constructor to get everything set up when a new object is made. And finally, you bring it to life using the new keyword. Boom, done.
Now here's a subtle but super important detail. TypeScript gives you two ways to make class properties private. Using the private keyword is a TypeScript-only thing. It's a check that happens before your code runs. But the hash symbol, the hash private, that's a true modern JavaScript feature that gives you real privacy that's enforced by the JavaScript engine itself when the code is actually running.
Ah, the this keyword. If you've ever worked with classes in JavaScript, you've probably wanted to throw your computer out a window because of this thing. Its value can change on you unexpectedly. But don't worry, TypeScript gives us some great ways to lock it down. You can explicitly define what this should be, use the classic .bind method, or, and this is my favorite, just use arrow functions for your methods. It's clean and it just works.
All right, so we've defined data shapes and we've built structures with classes. But now we get to what I think is the absolute magic of TypeScript. It's not just about what you tell it, it's about what it can figure out all on its own. This is something called control flow analysis.
So let's set the scene. Let's say we have a variable called input. We know it could be either a string or a number, but we're not sure which one. This puts us in a tricky spot, right? We can't just call a string method on it, like .uppercase, because if it's a number, our whole program will crash.
But watch what happens the second we add a simple if check. The moment we write if type of input equals string, something incredible happens. Inside that block of code, it's like a light bulb goes off for TypeScript. It knows with 100% certainty that input has to be a string. And suddenly, all those string methods are available and totally safe to use. This is called narrowing, and it's a total game changer.
And really, this quote just sums it up perfectly. At its heart, control flow analysis is all about taking a wide range of possibilities, a union of types, and intelligently shrinking that list down based on the logic it sees you writing in your code.
And hey, this doesn't just work for simple strings and numbers. It gets even more powerful with complex objects. If you have what's called a discriminated union, which is basically a collection of different object shapes that all share one common property, a switch statement becomes your best friend. Inside each case block, TypeScript knows the exact shape of the object you're dealing with. No more guesswork.
So let's bring it all home. When you take all these building blocks, the shapes, the classes, the smart analysis, and you combine them, you start writing code that is, in a very real way, self-defending.
So here it is, your TypeScript toolkit. You have your blueprints, using type and interface to perfectly describe the shape of your data. You have your structures, using class to bundle that data up with behavior. And watching over it all, you have the Smart Inspector, TypeScript's incredible control flow analysis, which understands your logic and helps you zap bugs as you type. And that leaves us with one final thought. When your code becomes self-describing, when your tools can understand it as deeply as you do, what does that unlock? We're talking about incredible auto-completion, refactoring code without fear, and building huge, complex applications with a level of confidence we just never had before. So the real question is, what new possibilities will that create for you?